Chapter 8, number 23. A skateboarder is at a skate park and rides along the path shown in the figure. If the speed of the skateboarder at point A is 1.4 meters per second, what is her speed at point B, assuming that friction is negligible? We know that the work done by gravity in descending a height h is mgh, where here I'm going to take h to be, let's give ourselves some space here, h is the difference between her starting height and the height of the other bump. So that distance is h. And we know that as we descend, gravity does positive work, and it turns out it doesn't matter what happens side to side, the work is mgh, where h is the vertical distance. But this is the friction is negligible, and therefore the only force acting is gravity, and so this is also the total work. And we know the total work is always delta k. So we're left with that, putting all of those guys together, we end up with that delta k is mgh. But delta k is a half mvf squared minus a half mv squared, and that equals mgh. I can bring this to the other side to have a half mvf squared equals 1/2 mv squared plus mgh. I then multiply by 2 over m, so as to clear it out on the left over here to end up with just vf square. But that means I have to do it 2 over m to the entire other side. And then something kind of weird happens. The 2 over m cancels that 1/2 m, and I get just v squared. And then the m cancels out here too, and I get m2 times g times h with no m in it. Which means that in the end, the mass of the skateboard rider is irrelevant, which is good because they give it to us, so we'd be in trouble. Also, you might notice that looks a lot like a kinematic equation, and it is the same form, but we couldn't use the kinematic equation because her acceleration is most certainly not constant. All right, it's an accident that for gravity it happens to all cancel out, but in general it's not a constant. All right, so then we just get the square root of v squared plus 2gh, or the square root of 1.4 meters per second quantity squared plus 2 times 9.81 meters per second squared times the height, which is 1.7 meters. And we throw that into a calculator. This equals 5.94 meters per second, but we only have 2 digits, so really it's 5.9 meters per second.